Hello, students. This video is going to go over the Module 7 demo Jupyter Notebook that I've got pulled up on the screen here. And this is the starting point for us for regular expressions, part 1. We'll be in regular expressions for 2 modules, maybe even a tiny bit more. The best way, again, to study, given these materials, is first to go through the book first, read it. And in this case, we're reading all the way up to chapter 6.7, section 6.7, I should say. And then these Jupyter Notebook demos are designed to supplement the book. So they won't make a lot of sense if you don't read the book. So read first, and then we can kind of delve into these. Now, with regular expressions, the basic operators that you'll see time and time again are going to be the plus sign and the asterisk. The plus means whatever the preceding character is, you can repeat it one or more times and it'll still be considered a matching pattern. And the asterisk means basically the same thing, except the value associated with that is 0 or more instances of the preceding character. So if we see here in this pattern that I'm highlighting here and circling with the mouse, we see that, okay, this is a pattern. We can establish that it's a regular expression because it starts with an R, and then it has a complete set of single quotes and some string inside the single quotes. And that string then is going to be our regular expression pattern. So in this case, we will say this pattern will match strings provided that they have an H and they have an E, and then we see L plus, so that means provided that next is one or more L's, finally followed by O, and that will generate a match for that pattern. And then here's an example. Here's just some code below in this cell. And before we run this or parse this cell too much, we do want to take a look at the dot match function here, regular expression dot match. And that's simply going to take a regular expression pattern that we created, and then it's going to analyze a target string, a candidate string, and see if those two match. Now, this print statement here is going to be a ternary operator kind of statement. It's got a print statement, and then embedded inside of it is this statement where we're going to print out response 1 if that condition is true, otherwise response 2, and then there is response 1 and 2 match and not a match, just those strings. Here is a simple Python list with a couple of candidate strings in it, targets. Here is our pattern, and we will use the same one that we just did, and then we'll simply run this. Give me 1 second to take care of that. There we go. And the way we will run this is that we will just simply step through the list of targets and analyze each one and evaluate it against the regular expression pattern. And if they're a match, then it'll say so. So we run this here, and we see right here, let me actually run this. We see right here that we get the results. There's the pattern that we needed to match. That was just hard-coded out. And then here are the results as we step through that list. The first and the second matched, the third did not. And the third did not clearly because we're required to have at least one L in these. Let me put a couple others in, and you can kind of see that that'll match, and let's do one more. Now this is interesting here. I put in HELLLOOO, and that actually matched. And that's because of the behavior of the regular expressions in Python. They will always start matching at the beginning of a string. And unless you tell it to terminate the string or to stop processing the string at this point, it'll allow follow-on letters. And I'll talk about that a little bit more below. Now let's modify our pattern just a little bit, where we're going to swap out the plus sign and give it the asterisk. And again, asterisk means 0 or more of these characters. So now the pattern is, it's got to start with an H, it's got to then be followed by an E, and these are lowercase. And then it can have 0 or more L's followed by an O. And then let me put a few more. Just a couple more examples there in that list that's going to test them all. And here we get some answers there. This time that HEO, well, it did match, and that's because we no longer require 1 or more L's. Now the requirement is 0 or more L's, and that has clearly 0. We get the same behavior though with this last one with HELLLOOO, and that's again because we're testing just the beginning of the string and we're not delineating that there is an end yet. However, we can do that, make that change right now in this next little section. We can add the end of string marker. So what this is going to do is we can insert the $ character, and that will say, okay, this is the official end of the string, and I will allow no other follow-on characters. So we alter our pattern here just a little bit by adding that $ as the very last character in the regular expression. And then when we run all of these, we see that we get pretty much the same results as before, except the pattern now requires exactly 1 O, and then the string terminates. And that's why these last 2 target strings are no longer matching, because they were before further on up, but now since we're saying, okay, there's got to be exactly 1 letter O at the end of the string, well, that knocks them out of the running. Now, we can also use the .full match method if we want, and that is going to take care of delineating the string limits automatically without us needing to put in either the $, character to mark the end of a string, or as we'll see later, there's the caret character that could mark the beginning of a string. Full match will just take the entire string, but there are some limitations to full match. It's good if you're just doing simple patterns like this. But we'll see later, there's some power-ups that we can do to the re.match method that aren't supported by re.fullmatch, and I'll show those toward the end. So here we did use full match, and that just meant that this pattern does not need the string terminating sign with the $, and we get the exact same results here that we just got, okay? Now, the next thing to add here is if we want to add specific characters to our pattern. So now let's say now we have a new requirement that in addition to saying hello, we want to say hello you. But the you will be literally spoken with the character you, either uppercase or lowercase. And the other requirement is that between the word hello and then the character you, there can be either or. There can be either a space or a dash. So all of these here will test out just fine. This one here won't though, because it's got the 1 too many O's there. And the way that we put these requirements into a regular expression phrase there is we use square brackets. And square brackets mean one character goes in here, and it can be any of these, but one character must appear from this list of characters that are inside the brackets, and that's called a character set. So here in this pattern, we're saying that pattern there, we're saying, okay, we're still in a regular expression that starts with an H, an E, and then has 0 or more L's, then a lowercase o, and then it must have either a space or a dash, and then either a lowercase or an uppercase U. And then there's the end of the string, and it will not take any other characters past that past the string there. Let me put a few more of these in, just to show how they may or may not work. All right, so I ran this. Again, here's our pattern. I'm using the dot full match method, same as before, and I'm using the same coding guts to just get this to process. And we can see here, okay, this one matched, that makes sense. This one matches, it's got 0 or more L's. This one matches because it's got 0 L's. This one does not match because it has an extra O at the end, as does this one and this one. None of those match because of the extra O's. But this one looks like it should match. I mean, we have an H, E, O, which is valid, a space, and a U, which is valid. But if you remember, the pattern said the last character has got to be that U. There's nothing accepted following that. And since this one has got an exclamation point following it, then it's not accepted. And we say that that's not a match. Now, this next little snippet, I took the code from the book, from the Social Security number validation code. And I'm going to zoom out actually a little bit here to get more of it on the screen. And this code here will validate if a Social Security number is in the right format or not. And then here's some targets that we can test. Now, this time the pattern is going to say, all right, it's going to ask for 3 digits, and the escape sequence \D stands for any digit 0 through 9. So the \D repeated 3 times means it's going to require 3 of those digits. Then we have square brackets again with either a space or a dash in it. So we'll accept Social Security numbers that have either dashes separating the number clusters or spaces. Then we have our 2 digits, and then we have the space or dash again, followed by the final 4 digits. And then if we see here, we see what matched and what didn't. Of course, those first ones matched. Didn't matter if it was separated with the dash or the space. And we see that last one did not match because it has an extra character at the end. It's not 4 digits at the end, it's 5, and that violated the pattern. So that's why that one didn't match. Now, this next little section talks about using the regular expression .compile method. And this is actually a good practice to get into. That's because, anytime you, for example, call this match pattern or full match, one of the arguments here is the regular expression pattern. So every single time we hit this statement, and it's going to hit this statement as many times as there are in the target array here, target list, every time we call that, it's going to call this, and this will actually run the regular expression generator because it's got an R at the beginning of it. And that's essentially a function call. Now, for small applications like ours here, I mean, we're just dabbling in a Jupyter notebook. The performance gain won't be even measurable. But for substantially larger applications, there is a performance tax for calling that, that generator. So a way around that is to just call it one time with a statement like this. Okay, pattern is going to now hold a variable. It's going to actually be a bona fide regular expression object. And if we call re.compile on it and put our regular expression string in there, well then it's just going to compile it once and store it to the pattern object. And this way means we don't have to run that function 15 times and suffer the penalty, the performance penalty because of that. We can just call it once. and save the other 14 times. Now here's, we'll get to this in a little bit later, but here's a little bit more of a complex regular expression. The escape sequence backslash lowercase w is what we'll use for any alphanumeric character, including the underscore character. So that means any A through Z, upper or lowercase, doesn't matter, or any digit 0 through 9, or the underscore character. Those all match in backslash W. Now, I'll go over this a little bit more in just a second, because this is going to be the regular expression that we can use to validate a 3-person or a 3-word name. And the middle name is represented by an initial and a period. And that initial, oh, by the way, has got the extra requirement that it has to be a vowel. But we'll get to that in a second. So here, the difference in the code now for this Social Security validator is we are going to call .compile on that expression. And because it's an expression inside the .compile method, you don't have to precede it with the character R. You can just put the pattern in there and it'll compile it and then assign it now to a variable called pattern. But the data type of this pattern is now a regular expression object, and we can just simply reuse it however we want. And then here is where we do that. Right here is where our pattern, our object, is being used, and we get the same results that we did before. All right, here's that code now that is going to validate a 3-word name where the middle name is represented by an initial that must be a vowel. So here's what the pattern is, and let's just break this apart. The first backslash W says, okay, any alphanumeric character. But then there's a plus sign right after it. So this just says, okay, it requires 1 or more alphanumeric characters followed by a space. And that's going to then represent the first name. And then it requires 1 of those vowels. You see a period there, and that means that it's got to be followed by a period. And then we have that same sequence of backslash W plus sign, which will capture the last name just like it captured the first name. Backslash W again is going to match any alphanumeric character, and the plus sign gives us the requirement that there has to be 1 of these characters minimum or more. So then here's some code now that we'll take a look at and see if these work for us. I'm going to separate it all here. There we go. I'll separate it here so we can get it all on the screen. But when we see here, I've got a bunch of targets here. I've got a very long list here of some things that I'm wondering if they'll comply or not to this new requirement. Here's the string, and I'm just going to first store this into a string variable, and then later I'll just call that string right there for the compile. And we do this so we can actually print out the string. All right. Then here, our first output line is going to be, here's the string that we're trying to match. And then we're still using full match, and let's see what kind of results we get. So let me run this, and then there's all of the results that we got as it stepped through that list to see what is what's contained in the match set and what's not. This one here is not a match, clearly because the middle initial is not a vowel. This one does match. This one fails validation because there's no middle initial. This one matches. This one matches also, even though the first name has just 1 character. And we can ask ourselves, well, why is that? And it's because that very first tag of backslash W plus says we can have 1 or more, which means a minimum of 1. And here in this name, we have a minimum of 1. Matter of fact, we can do that for the last name as well. and see that that matches because the last name just needed to be a minimum of 1 character. This one clearly doesn't match because the first name is succeeded by a period, and that's unallowed. And then same thing, this last name is not allowed either because the last name is succeeded by a period. All right, now if we go back to using dot match, then we can throw in a little function flag here. We can tell it, okay, any of these things. You can ignore upper and lower cases when you do this comparison of the pattern and a target. When you compare those, tell it to ignore upper lowercase. You can tell it to ignore extra white spaces that might be present within the pattern. Some developers like to kind of space out and spread out their regular expressions so that the logical groupings make sense. And then there's the re.s, which is the dot operator, which means that normally the dot operator will match all characters. And if you use re.s, the dot operator, or the dot, I should say, will match all characters, including the new line character. So that's sort of a more advanced thing. I don't think we use that in our coding here, but it at least is there. Now, this is the one where these functions are not available with full match, not supported. So we've got to go back to match. So here's just a little snippet of code from the book. And this is saying, okay, if we get this pattern matched here against this target, and then we're going to call re.i, which is going to tell us to, or tell the matcher to ignore upper and lower cases, then we'll get success or not. So let's see, this regular expression, it looks like it needs either a lowercase or uppercase m, and it can be any number of those, 0 or more, followed by the characters ACK in that order. Now this next one here shows you can use re.x, and that's going to ignore the spaces, and you can see here that we did put a space right here, but when we run this, it still works, so we get a success message. Now going back to this one, we can have any number of m's there followed by ACK, and since we aren't terminating the string there, it can have anything else that we want. So that's why when I just ran this cell here, we still got a success with multiple m's. Same thing if we had, if we put a string terminator here, well then suddenly we would get not so successful because this string here, this candidate string, has got a bunch of follow-on characters. All right, now the next section talks about meta characters and character sets. And what I need you to make sure to do is really carefully review that table 6.2, because that's got the most popular meta characters. I've repeated some of those here. And these meta characters are just simply, substitute characters, new kind of escape sequences that we can use. And they really allow us to up our game and match even more things. So the dot is going to match any character whatsoever, except the new line. And of course, if you want to include the new line, well, then you use the re.s tag, or that function call, that function flag, I should say, in the dot match list of arguments. The caret marks the beginning of a string here. Just like the $ marks the end. Backslash capital A also matches the beginning. Backslash lowercase z also matches the end. So we've got some, ability, or the ability to mix and match there. Here's that backslash w, which matches all alphanumeric characters plus underscore. If we capitalize that and make it backslash capital W, it's going to be everything not included in backslash lowercase w. So this would match all other non-alphanumeric characters. So if backslash lowercase w includes these characters, then backslash capital W includes every other character that's not in this set. Then we have that same sort of a setup with backslash lowercase s. That'll match all white space characters. And then backslash uppercase s will match any non-white space character. And if we remember right from our coding experiences, a white space is not just the actual space character, but it also includes things like the tab, the carriage feed, the new line, etc. And then finally, we saw this before, that backslash D will match any digit character, 0 through 9. So now this next little section just talks about how we see just various combinations of these character sets. We saw character sets up above. Anytime you've got them in a square bracket, it means, oh, if that's the character set, you must choose one of these. So if we remember right for this code, that's going to require us to select one of those. Now, what we can do if we wanted to require 0 or more vowels is to actually use this code. We can take a character set and then succeed it with either a plus sign or the asterisk, and that will require that to be repeated that many times. So in this case, it's going to be 0 or more times that vowel pattern is really repeated. This one is going to require a 6-digit hexadecimal code. How do we know that? Well, in braces, we see the integer 6. And that syntax says, all right, pick one of these characters inside the braces 6 times. This one here is going to require one of these math operators to be used. Plus, minus, divide, times. However, if you precede it with the caret operator in this case, it acts as the not operator. So this one is going to match with anything that is not one of these math operators. So there's some other pattern qualifiers here that we can use. This one we've been using already with the character plus and the plus sign. This is the character and the asterisk for 0 or more occurrences. We can use a question mark, and that's going to match for either 0 or 1 occurrence of that expression. Let me say that again, either 0 or 1 occurrences. So that's going to be the breakout then of those 3 characters. The plus sign is 1 or more, the asterisk is 0 or more, and the question mark is 0 or 1. So it's definitely a MECE set there, and we've got everything covered. This line here will match for either expression 1 or expression 2. And that or sign is just like we use in coding. Here's the square braces with a number. It's going to match for n occurrences in a row of that expression. You can explicitly code in the minimum and maximum number of times and make it kind of variable, m for the minimum and n here for the maximum. And then you can kind of mix and match how we put these in relation to the comma to specify a minimum, a bare minimum of at least m occurrences, or a maximum of at least, or at most, n occurrences. And then finally, if we wanted to group expressions together, we put them in parentheses. So that way, if we were to then use one of the repetition quantifiers, it would operate that on the entire set and not just on specific components there. So the one thing that we can do here is, well, let's go back to that Social Security code that we had above that validated a certain pattern as to whether or not it is compliant with the Social Security format. So here highlighted, that's the old code where we had like DDD all together. And we can tighten that up a little bit now that we know that we can just put \D and then in braces, put a number, and that's the number of times that it's going to be repeated. So this new code here that's highlighted is the improved regular expression. And of course, we're going to use it and call compile. We're going to then put that into a regular expression object that we can then use. Now then, here as this last example, this is from the book, and I've modified the example a little bit. This is a password validator. And, just like if we're coding part of a website, it's going to ask us, all right, here's a password candidate that a customer wants to use. And is this compliant or not with the 4 rules that our bank has? And here are those rules. That every character has to either be an alphanumeric character or one of those special characters that's listed right here. Otherwise, there can be no other characters in the set, including things like a space or a tab or anything else. It's just those there. In addition to that, we are going to demand a minimum of 8 characters. And after those characters, there can be no other follow-on trailing pieces of data. So that's the first requirement. The second requirement is right here. It's saying that, okay, there can be 0 or more characters of any type. But if they precede then a digit, well, then that's going to be a match. And this is going to satisfy that requirement that you've got to have at least one digit in your code. Here's another one that's going to say, okay, you can have anything in front of it, but the requirement is you've got to have at least one alphabetic character. So you could have a whole series of special characters and numbers, but this is saying, okay, somewhere in there you need an alphabetic character. So this is saying that if we were to bust this up, dot asterisk says 0 or more characters of any type, followed by a single instance of A to Z is going to meet this requirement. And then this last one is going to do the same thing. It's going to say, all right, somewhere in your password, you've got to use at least one of these special characters. So that'll be met by, again, if we've got anything followed by one of these special characters, well, then that requirement is met. Here, then, I created just a very quick function called verify password. It'll receive a candidate string, and it will return if all of those patterns are matched. It'll return a true. All right, then here's our targets, and we've got a bunch of password candidates there. And then we'll just use a for loop to step through those strings. We're going to send str to the verify password function. If we get a true back from that, well, then we will output response number 1 that we've got defined way up there. And if not, then there's response 2. And then we can see that all of these outputs are what happened. And we can see, all right, this one works because it's got an alphanumeric character, a digit, and a special character. And it's at least 8 characters. This one's not a match, and we can see why there. It's got no special character in it. Okay, this one's not a match because it has an extra special character, that right parenthesis, but the right parenthesis is not one of our approved special characters, so that's why that one didn't match. But this one did match. Okay, it's clearly more than 8. I see a digit, I see an alphanumeric character, and I see 1 or more special characters. So that's why that matched. All right, gang. Well, I hope that this was a good refresher. I encourage you to download this module demo and play with it and just start running things and experimenting. A good idea, remember, if you haven't executed the code further on up and you want to start playing with this one, this cell here, it's going to draw an error because I'm using some code that was already declared further on up. So a nice, easy way around that is to, as soon as you open up a book, just do cell run all. Just let them all run. And now any previous variables or objects that we are relying on for this cell have already been committed to memory, and they're available for us now. So this would not pull an error. Okay, good luck, students.